Welcome to our demonstration highlighting the cost optimization capabilities of StormForge Optimize Live and Karpenter by AWS. As we begin, let's understand the scale of resource waste in Kubernetes environments. A recent industry survey showed that almost 70% of provisioned CPU and almost 20% of provisioned memory go completely unused. For organizations with large Kubernetes deployments, these wasted resources can amount to $10 million or more per year. And this cloud cost and resource waste problem is pervasive enough that 82% of surveyed organizations are implementing FinOps practices to help bring these issues under control. For our demo, we'll start with a Kubernetes cluster that is constructed to highlight the costs of a specific application and the cost optimization benefits of both Karpenter and StormForge's Optimize Live. We start by separating out our autoscaling tools so that their usage does not influence the cost of our application. Second, we have a dedicated set of nodes on which we run a set of load generators for our applications. These will generate the workload usage metrics Optimize Live will analyze for its right-sizing recommendations. And lastly, we will focus our demo on two groups of nodes, the first of which is autoscaled using a traditional autoscaling node group and cluster autoscaler. This will serve as our control. The second group of nodes will be provisioned by Karpenter. Our demo methodology is simple. We'll deploy a standard microservices application to the first group of nodes, scaled with cluster autoscaler. We'll then deploy the exact same microservices application to a set of nodes provisioned by Karpenter. It is on this set of nodes that we'll also apply a set of right-sizing recommendations generated by Optimize Live. We'll then conclude our demo by showing the costs of the nodes for each of these scenarios. Let's take a look at some key differences between a standard autoscaling node group configuration and a Karpenter provisioner. In our managed node group configuration, you can see that we have an array of instance types and that they're all the same resource shape. This is an important consideration to make when creating and managing node groups. We've also chosen to stick with on-demand instances to keep things simple. By contrast, our Karpenter provisioner has no instance limitations. It may provision any instance it wants, so long as it meets a short list of requirements. As with our node group, this provisioner also chooses on-demand instances. With our application deployed using the appropriate node selector for our control node group, we can use EKS Node Viewer to look at the costs of the application using a specific node label. Our traditional node group is labeled with CA control. We can see that we've provisioned 7 nodes and they're all M5X large. And it looks like the monthly projected costs will be about $981. Separately, we've also deployed the same application using a different node selector for our Karpenter provisioner Karp on Demand. In this case, you can see that Karpenter has provisioned a different set of instances, amounting to about $721 per month, a substantial 26% cost savings. But this begs the question, if we right-size all of the deployments based on their actual usage and instead of some arbitrary request values, could Karpenter save us even more money? Now let's take a look at Optimize Live, our machine learning-powered continuous workload right-sizing tool. To get started with Optimize Live, simply visit the website URL on the screen to sign up for a free 30-day trial. Next, once your account is confirmed via email, you can begin the Getting Started workflow to add your first Kubernetes cluster. A series of pre-formatted commands makes this process incredibly simple. And once the pre-formatted Helm command has completed the installation of our StormForge agent, the agent will automatically begin discovering, analyzing, and generating right-sizing recommendations for all workloads in your cluster. The copy of our microservices application that we deployed into our Karpenter provision nodes is in this e-commerce 2 namespace. Here we can see each of the individual microservice deployments along with their right-size values listed as CPU, memory, and their respective impact. While each of the individual workloads has a set of recommendations, we can see in aggregate that this application can be optimized to reduce total CPU requests by over 9 cores and memory requests by over 30 gigabytes. In addition to our UI, you can also use the StormForge CLI to view and download recommendations. The recommendations themselves are available as either YAML or JSON objects. And for workloads that are scaled using an HPA, Optimize Live will automatically detect them and generate a corresponding patch to ensure that the workload scales consistently while accounting for the change in vertical pod size. To apply the patches, we have several options. You can deploy the optional StormForge applier, which allows you to apply the patches to each workload individually by using the Apply Now button located in the GUI. We can also set each workload to automatically deploy new recommendations using a schedule. But today, we'll use the StormForge CLI to apply all of the recommendations for our eCommerce 2 namespace. With the right sizing recommendations for our microservices application successfully deployed, we can go back to EKS Node Viewer and watch as the resource requests are adjusted, the deployments rolled out, and as Karpenter reprovisions the nodes to right-size the underlying compute capacity. We can see that Karpenter is able to bring the monthly cost down for our application from $721 to about $250, a nearly 75% reduction in instance costs when compared to our original cluster autoscaler configuration. I hope you enjoyed this cost optimization demonstration using Karpenter and Optimize Live on Amazon EKS. For more information or to sign up for a free trial of Optimize Live, please visit us at www.stormforge.io.